Hi students, today we are going to see the revision for the first volume, and in the first chapter electrostatics, and in electrostatics this is the first part which is having some introduction. And so here next basic properties of charge, and you have to see the value. The SI unit of charge is coulomb, and you have to study about conservation of charges. So the total electric charge in the universe is constant, and the charge can neither be created nor be destroyed. That you have to study. Then Q is equal to Ne. Q is the total charge, and N is the number of electrons, and E is the charge of electron. And Coulomb's law. And in Coulomb's law, you have to study Coulomb's law. This is a statement. Coulomb's law states that the electrostatic force is directly proportional to the product of the magnitude of the 2 point charges, and the inversely proportional to square of the distance between the 2 point charges. It is like gravitational law. And next is the SI unit of permittivity, and you have to compare the electrostatic force and the gravitational force. And next we are going to see about, these are some example problems. And next superposition principle. So we have to study this superposition principle, which is in bold letters. The total force acting on a given charge is equal to the vector sum of the forces exerted on it by all the other charges. That is the superposition principle. And next we are going to see about electric field and electric field lines. So you know, electric field is defined as the force that would be experienced by unit positive charge placed at that point. That you have to study. E vector is equal to F vector by Q naught. This is very very important formula. E vector is equal to F vector by Q naught. Next, important aspects of electric field, and you have to study these properties of electric field. And the first point is, if the charge is Q is positive, then the electrical points away from the source charge, and if Q is negative, the electrical points towards the source charge Q. So that is the first point. Then you have to find out the electric field at a point is E vector, then the force experienced by the test charge Q naught is usually the test charge, and you have to write the Coulomb's law in that. And the third one is, the electric field is independent of the test charge. Test charge is the charge used to test what is the amount of electric field there, and it is independent of the test charge Q naught. Electric field is independent of the test charge. That is the third point. And the fourth one is, electric field is a vector quantity. That is enough. You can write the fourth point in a simple form. And in the fifth point, the test charge is sufficiently small such that it will not modify the electric field of the source charge. So usually the test charge is very very small, so it will not affect the source charge. That is the fourth point. And you have to write the sixth point. So it is valid only for point charges, and so as we are considering Earth as a point mass in the gravitational, and that is the sixth point. And seventh point is, there are two kinds of electric field: uniform electric field and non-uniform electric field. And you have to explain what is uniform electric field and what is non-uniform electric field. So these are the 7 important aspects of electric field, and you have to study these important aspects. Then electric field due to the system of point charges, and you have to write study what are electric field lines and the properties of electric field lines. The properties are given. And electric dipole. What is electric dipole? Dipole is two equal and opposite charges separated by a small distance. That will constitute the electric dipole. And you are having electric field due to a dipole. That is, two cases have given: axial line and equatorial line. For axial line, you have to consider the point C is along the axial line of minus q and plus q, and you have to find out E plus vector and E minus vector, and you have to find out the total electric field E1 vector E plus vector plus E minus vector, and you have to find the resultant one. And for equatorial line, the point C is somewhere on the equatorial line, that is in between A and B. In that the derivation is different. You have to find out E total, and you have to find out E plus vector, similarly E minus vector, and you have to find out E total. Here you have to apply the Pythagoras theorem, and before that you have to separate E plus vector into two components, E plus cos theta and E minus E plus sin theta, and similarly you have to resolve E minus vector into two components, and you have to derive the equation. This is about axial line and equatorial line. And next, electric potential and potential energy, and you have to define what is electric potential and potential energy. So this is the definition for electric potential. You mark that and read. So it is the work done by an external force to bring a unit positive charge with a constant velocity from infinity to the point P in the region of the external electric field. And next, electric potential due to a point charge. So you have to derive this equation. V is equal to 1 by 4 pi epsilon naught into Q by R. And these are the example problems. So this is electric potential at the point due to an electric dipole. So here you have two dipole minus Q and plus Q, A and B, and you are finding out what is electric field at a particular point P, and you are deriving the equation. This is also a 5-mark question. And next, what is equipotential surface? That is the surface in which all the points are at the same electric potential, and the properties are given, and you have to mark this relation between electric field and potential. E is equal to minus dV by dx. So next, electrostatic potential energy for collection of point charges. So this is electrostatic potential of a dipole in a uniform electric field. And next, Gauss law. The Gauss law, before going to Gauss law, you have to study about electric flux. So electric flux is nothing but the number of electric field lines crossing a given area kept normal to the electric field lines is called electric flux. And you have to study the unit Newton meter square C power minus 1. And so here from the electric flux you have this formula, phi E is equal to E vector dot A vector, that is EA cos theta. And these are about electric flux for closed surface. Next, you are having Gauss law. So the Gauss law, here this is the definition, that is a statement. If a charge Q is exclosed by an arbitrary closed surface, then the electric flux phi E through the closed surface is given by the formula phi E is equal to integration over a closed surface E vector dot dA vector, which is equal to Q enclosed by epsilon naught. This is Gauss law. And here there are 3 or 4 cases for applications of Gauss law. Electric field due to infinitely long charged wire, and you are having different cases, charged planar sheet, like that you are having. And the fourth one is uniformly charged spherical shell. So these are about Gauss law. And next you are going to see about electrostatics of conductors and dielectrics. So a conductor at electrostatic equilibrium has some properties that is given, third point, and you have to study the up to 4 points. Just you read the letters which are in the small form. And next, electrostatic shielding. So electrostatic shielding means whatever be the charges at the surfaces, from that you have to write up to, this is called electrostatic shielding. And you have to write about electrostatic induction. So electrostatic induction. Next you are having about dielectrics or insulators. For that you have to study non-polar molecules and polar molecules. And you have to study the definition for dielectric strength. Then what are capacitors? Capacitor is a device used to store electric charge on electrical energy. That is a definition. And you have to read that capacitance. Define capacitance. So define capacitor is different from capacitance. It is defined as a ratio of the magnitude of charge on either side of the conductor plates to the potential difference existing between them. That is C is equal to Q by V. This is very important formula. C is equal to Q by V. And so these are about the capacitors and what is the energy stored in the capacitor. Then application of capacitors is given. You have to study these applications of capacitors. And next you have to read about capacitors in series and parallel. So what happened to the effective capacitance when they are connected in series and also when they are connected in parallel. So next, distribution of charge in the conductor. So here you have to read what about the radius. For smaller the radius, the charge density will be larger and vice versa. And you have to read the definition for action of points. And lightning arrestor or lightning conductor is a 3-mark question. And next comes Van de Graaff generator. And you have to draw this diagram. The above diagram is not necessary. You have to draw this diagram. And you have to mention about BC are the pulleys, ED are comb shaped conductors, and the rubber belt is passing through the pulleys in the anti-clockwise direction. And they are giving a very small potential to the comb D, but you are getting very large potential at the sphere. That is, the positive charge is on the positive charges are stored on the outside of the sphere. So in this, the main thing is you have to read. First you start from principle. So principle is electrostatic induction and action at points. That is enough. Just write the topic principle. The principle is electrostatic action, induction and action at points. And the second paragraph is about the description. A large hollow spherical conductor. This is a setup, that is a description. And the working is from due to high electric field. So the comb D gets positive charge, and the belt, by the action of points, the positive charges are pushed towards the belt. So the belt will have positive charge, and after reaching the point A, the comb E occurs negative charge and the sphere occurs positive charge, because opposite charges are induced, and so you are having positive charges on the outer sphere, and this process continues till you reach the voltage 10 power 7 volt. And you have to write the uses of Van de Graaff generator. A very high voltage is produced with the help of Van de Graaff generator. So this is about the revision of the first chapter. And next we are going to see about the revision for the second chapter, current electricity. So in current electricity, you have to define what is electric current. So then current is defined as I is equal to Q by T. Now write that definition. The unit for current is ampere. And next, drift velocity. You have to define what is drift velocity. Drift velocity is the average velocity acquired by the electrons inside the conductor. And microscopic model of current. In microscopic model, you will get a J vector is equal to sigma E vector, whereas microscopic form is different from macroscopic form. Why? Current density is a vector but current is a scalar. This note you have to read. Next comes Ohm's law, and you have to read about Ohm's law. And before that, what is the definition for resistance? R is equal to V by I. So you have to write the SI unit of resistance is ohm. And next you have to define what is resistivity. That is, a reciprocal of conductivity is called resistivity, and various values are given. And here this is the definition for electrical resistivity, and the tabular column is given here. Then as the capacitor series and parallel, you have to read resistor in series and resistors in parallel. So here these are for 3 marks. And color coding, based on color coding you will get problems. and temperature dependence of resistivity. How to read this definition? This is temperature coefficient of resistivity. And next, energy and power. You have to define what is energy and what is power. So what is value of 1 kilowatt hour? 1 kilowatt hour is equal to 1000 watt. So 1000 watt into 3600 seconds, that means 3.6 into 10 per 6 joule. That value you have to read. And next, electric cells and batteries. So we have to read what is internal resistance. And these are example problems. And here also cells in series and cells in parallel. And next, we are having Kirchhoff's first rule and second rule. This is the first rule, that is algebraic sum of currents at any junction is 0, and the closed algebraic sum of product of the current and resistance of each part of the circuit is equal to the total EMF induced in the circuit. Sum of algebraic sum of product of current and resistance. That is very, very important. You have to write algebraic sum. Definitely you should write. Next, Wheatstone bridge. Wheatstone bridge is usually asked. And this is meter bridge and potentiometer. So in potentiometer you have to read for 3 marks the principle of potentiometer, and next comes the comparison of EMF of two cells with the potentiometer. So you are having this circuit diagram. One EMF is epsilon 1 and the other is, you can take it as E1, and other EMF is E2. You have to compare E1 and E2 using this circuit. So C and D is nothing but a potentiometer. So here battery, key and the rheostat are connected, and E1, E2 are the EMF of the two cells, and it is 6-pole, 6-way, that is you can call it as double pole double throw switch. A galvanometer and high resistance and jockey is connected, and here you are getting two equations. E1 is equal to IR L1 and E2 is equal to IRL2. You have to find out E1 by E2, which is equal to L1 by L2. Here internal resistance of a cell by a potentiometer. Next, you are having heating effect. This, the Joule's law is important. That is, the heat developed in an electrical circuit due to the flow of current varies directly as the square of current and resistance of the circuit and the time of flow. That is, E is equal to H is equal to I square RT. And so here some applications are given, and you have to read the 2 mark Seebeck effect, Peltier effect and Thomson effect. So this is the end of the second chapter, and you have to read all the book back 1 marks and the solved problems. And when you see the example problems, you can read the solved problems. This is 227. That is, you are having the formula H is equal to I square RT. Using that formula, you can find out the heat energy produced. Similarly, for example 228. For that also you are using the Joule's heating law. H is equal to I square RT, and here you are finding out the heat. The amount of heat energy Q is ms delta T. This is from 11th standard, and if you know S, you can find out time. Time T is given by Q by I square R. Substituting that, you can find out the time required to produce this heat energy. So you can read all the solved problems in this chapter. Next we shall see the revision for the third chapter, magnetism and the magnetic effects of electric current. And so here some basic definitions are given. You have to find out the dip, declination and inclination. These are the basic properties of magnets, and some properties of magnet is also given, and you have to find out you have to read the magnetic field line properties and similarly magnetic flux. We are having both electric flux and magnetic flux, and Coulomb's inverse square law, that is same as Coulomb's inverse square law in electrostatics. Instead of charge you will write pole strength, that is enough. And a magnetic field at a point along the axial line of the magnetic bar magnet. So you are having a bar magnet which is shown in this diagram, south pole and north pole, and you are going to find out what is magnetic field at the point C. For that you have to consider Bn is magnetic induction due to north pole and Bs is magnetic induction due to south pole, and the total length of the bar magnet is considered to be 2L. Used on this you find out Bn vector, Bs vector, and the total magnetic field is B vector is equal to Bn vector plus Bs vector, and adding that you can take mu naught Qm by 4 pi outside, and r minus L the whole square and r plus L the whole square will become r square minus L square the whole square, and you can substitute for Qm2L. Qm2L will become Pm, that is magnetic dipole moment. Substituting all these values you will get B axial, which is given by mu naught by 4 pi 2 Pm by r cube into I cap. Here mu naught is permeability of free space, epsilon naught is permittivity of free space, and you know Pm is the pole strength. So this is about axial line. Similarly you can find out for equatorial line. And so here magnetic properties, you can read magnetic permeability, magnetic susceptibility, and the relation between them. And there are different types of materials: diamagnetic materials, paramagnetic materials, and ferromagnetic materials. Their properties are also given, and you have to study Curie's law. Psi m is proportional to, inversely proportional to 1 by T, that you have to read. And so hysteresis, just read what is hysteresis. Remanence, you can read the definition for remanence, and you can compare soft ferromagnetic materials and hard ferromagnetic materials, and you Maxwell's right hand corkscrew rule, Biot-Savart law. This is Biot-Savart law. First point, second point, third point, and you have to you are having 4 points, and combined you can write dB is equal to mu naught by 4 pi I dl vector cross r vector divided by r square. And so this is magnetic field due to a long straight conductor carrying current. So you have to write the using Biot-Savart law you can derive this equation, and this is about axis of the current carrying circular coil. And so tangent law, what is tangent law you should prepare, and Ampere circuital law. So Ampere circuital law is given along with the equation 351, you have to write. And cyclotron, toroid, Lorentz force F vector is equal to Q into V vector cross B vector. That equation you should know. Then motion of a charged particle in a uniform magnetic field, that is also another derivation. So cyclotron. Next, force on a current carrying conductor on a magnetic field. And here conversion of galvanometer into ammeter and voltmeter. So here how will you convert the galvanometer into ammeter? By connecting shunt resistance, that is low resistance in parallel, and you have to find out what is Ig. And how will you convert galvanometer into voltmeter? By connecting high resistance in series. There low resistance in parallel, here high resistance in series. So you have to write galvanometer into ammeter. Also I have to write about galvanometer into voltmeter. So each one will be asked for a 3-mark question. So far we have seen about the revision for the 3 chapters.